distinguished panelists and participants. Bharati Vidyapeeth Institute of Computer Applications and Management, BVI CAM, in association with Computational Intelligence Society, CIS chapter of IEEE Delhi section, Computer Society chapter of IEEE Delhi section, Technology and Engineering Management Society, TEMS chapter of IEEE Delhi section, System Man and Cybernetics SMC Society chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity CNA Group of IEEE Delhi section, Life Member Affinity LMA Group of IEEE Delhi section, Inter-Society Relations IRS Standing Committee of IEEE Delhi section, Industry Relation and Special Interest Group on Humanitarian Technology Site Standing Committee of IEEE Delhi section. Region 10 of IEEE with the Associations of Computer Society of India CSI, Institute of Information Technology Professionals IITP, ISTE Delhi section and IETE Delhi Center as technical collaborator. Welcome you all today to this IEEE IETE BVI CAM technical lecture series on microservices architecture. According to Sam Newman, you should be thinking of migrating to a microservices architecture in order to achieve something that you currently can't achieve with your existing system architecture. In the ever-evolving landscape of software development, traditional monolithic architectures are becoming increasingly obsolete. The rise of cloud computing, big data, and real-time web applications has given birth to microservices architecture. This flexible and scalable approach is revolutionizing the way we build software systems, enabling organizations to respond faster to changing market demands and deliver innovative solutions with greater ease. Traditional monolithic architectures have long been the norm, but they come with limitations when it comes to scalability, maintainability, and resilience. The traditional one-size-fits-all approach can lead to rigidity, inflexibility, and a host of other issues that make it challenging for a modern application to adapt to the changing requirements. Microservices architecture is based on the simple yet powerful concept of breaking down monolithic applications into smaller independent services that communicate with each other through API. This modular approach allows for greater flexibility, autonomy, and maintainability, making it easier to adapt new technologies and integrate third-party components and deploy systems at scale. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would now first welcome amongst us our expert speaker, Mr. Abhishek Singh, sir, with an e-bouquet. Welcome to the session today, sir.
Thanks, Dr. Ritika, for inviting me here, and thanks to the complete BPI camp.
Thank you, sir. Abhishek Singh, sir, is a Delhi University alumnus with more than 11 years of industry experience, having worked with companies like Ericent and Ericsson. He is currently working as software architect at Harman, which is a multinational conglomerate company that designs, manufactures, and markets consumer and professional audio equipment, automotive, electronics, and infotainment systems. We are honored to have you amongst us, sir, and I would now request you to kindly enlighten the House. Over to you, sir.
Thank you, Dr. Ritika. So let me share my screen and then
Yes,
we can start. Okay, so let me know once you are able to see my screen.
Yes, sir, I can see your screen.
Okay, so then we can start.
Yes, sir.
So microservices architecture is used in almost all the modern applications that we are using right now. So right now we use Amazon for online shopping, right? So we use Amazon. We use Netflix, right, for watching TV series, movies, and all. and we use Uber and Ola apps for booking our cabs. So all these applications at backend uses microservices architecture. So the today's agenda for the webinar is that we will be discussing about microservices, key characteristic of microservices, benefits of microservices architecture, monolithic versus microservices architecture. So monolithic, you can think of it as a completely opposite of microservices architecture. Okay, so in microservices, we have small different independent microservices. In monolithic, the complete application is a single unit. Next, we will look into the components of microservices, challenges in implementing microservices, tools and technologies that are used for developing microservices architecture, some case studies, and then we will finally conclude. So microservices definition says that it is an approach where a single application is developed as a set of small independent services that communicate over a network. The goal of it is each service is focused on a specific business function, is independently deployable, and can be written in different programming languages. Think of a large e-commerce platform like Amazon, where the payment catalog and user authentication services are separate microservices. So if we consider our e-commerce application, what we do there, we have multiple functionalities, like we create a user, we register on the app, we log in into the app, then we explore different products, and then we do the order and we do the payment and all. So if you see, we have multiple functionalities that is there for a single application. So as per microservices, we create different microservice for all these functionalities. Now, to understand microservices, we must understand what is the monolithic architecture. Now, before microservices came into picture, the old application that were like 10 years back, 20 years back, all the applications that were developed were all using monolithic architecture. So the monolithic architecture is easy using three-tier design architecture. What is a three-tier design architecture? It is basically whenever we interact with any application. So we have a front end, which is our mobile app or our website. Okay. Then we have the business logic, that is our backend. And then we have our data store, the databases where we store our data like product data, the user data and all. Now, monolithic architecture is easy to implement as all the implementation is done in a single code base. The small application can be developed easily using a development team, which create a single project for the complete application. So right now, whenever when we do a college projects, usually we are creating a monolithic architecture, because what we do, we create one single folder, we write all our codes and put it in that folder, and then we run that application. So all application and projects that we develop during our college days are all monolithic architecture. Also, it's not like, in today's world, we don't use monolithic architecture. If the application is a small application, like if you want to create a to-do application, a medium or small projects can still be developed using monolithic architecture. Microservices architecture is effective when we have a large application to develop, like e-commerce, like Netflix, Uber. So now let's discuss on the monolithic versus microservices architecture. So monolithic architecture, monolithic architecture is a single unit. Just give me a minute. Let me reshare it.
Sure, sir.
So monolithic. So monolithic architecture is a single unified code base. It is a tight coupling, okay, because since all the functionalities are in a single unit, in a single code base. We have all the functionalities like if we consider e-commerce developed in a monolithic architecture, then all the functionality that user registration, searching for products, doing the payment, and everything will be in a single component. So all those application functionalities and services will be tightly coupled. Any change required deploying the entire system. So suppose there is any feature or functionality that we are adding to any single service, like if you are adding, suppose we have a simple application, e-commerce application where we have user registration and we have product management. And suppose in a product management, we are adding some additional functionality. Now, to redeploy that application, we need to deploy the complete solution, which will also have the user services, which will also have the orders of payment services and everything. So deploying or redeploying a microservices is a difficult task, and it is also a time consuming. So this is the very high level diagram for a monolithic architecture. So you can see here, it has a user interface, which is our mobile app and a website. Then we have the business logic. So whenever we interact with our application, okay, so like when we do a user registration, we fill the form, and when we click the submit button, the request goes from the user interface to the business logic. And from the business logic, it is the user data is finally stored into the database via this data interface. Now, microservices architecture. So it says it is a decoupled services, each focused on a specific function. Like we discussed 3 or 4 functionalities again, the user service, the payment, order, inventory management. So all will be created into a different microservices. There will not be a single unit, but a different microservices. Easier to scale and deploy and maintain. Since we have distributed this a single unit into different small microservices, the code base is also reduced. Also, the testing time, which is which we take to test that microservice is also reduced since it is independent and is small. And also the deployed time is also reduced. Can be developed, tested, and deployed independently since these microservices are independent microservices. Okay, so what is the limitation of monolithic architecture? So first is that the monolithic architecture has a complex code base because everything is inside a single folder or a single project. So what happened is due to this, understanding the project is difficult and development is slow and onboarding is slow. So like if any new member joins your team, then you need to train that team member on a complete uh, application where we need to understand the user registration, we need to understand the orders functionalities, the inventory system functionalities, and all other functionalities that are related to that complete application. So onboarding a new member is a time-taking process because you need to understand the complete application. Also, there is a scaling issue. Again, since the application is a single unit, any small change is going to be impacting the complete project, the complete service, and testing, deploying is all going to take a lot of time. Next, upgrade is difficult. So if you want to, upgrade or add any new functionality to a product service, you can do it, but to deploy that, now again, you need to completely run, test, and build the complete project, which is going to take time. And usually the monolithic architecture, usually the code base size is used. So it has around, I think, in GBs. And when we build that monolithic architecture, it takes around 1 hour, 2 hours to build a complete microservices. So it is always very time consuming. Also, we have a technology limitations. So suppose we have a monolithic architecture. Now, since it's a single unit, you cannot use different programming languages. You need to rely on one single programming language. Now it comes to that in future there is some new functionality and which is easy to implement in any other programming language. So suppose you have a microservices architecture in a Java programming language, and there is a new technology and you want to use Python for it, then you cannot use it because it is it will take you need to use Java only because the project is made completely in Java. Next, the key characteristic of microservices. So microservices is decentralized. Each service is autonomous and has its own database or state. So every microservice will own its own database. So since the microservice is independent, we keep the data of that microservices related to only that microservices. If multiple microservices needs to use that data, then the microservices needs to interact with each other to use that data. So every microservices needs to be independent, and also the database is owned by that microservices only. Services can be updated or deployed independently without affecting other services. Technology agnostic, again, different microservices can use different technologies and different programming languages. Since the microservices are different, you can use any programming language. Like you can develop one microservices using Node.js, you can develop a second microservices using Java, and you can develop a third microservices using Python. Scaling microservices is also easy. So suppose there is a traffic on a product registration, right? So suppose, sorry, product registration, I'm saying on user registration. So if a traffic is increasing on user registration, then you need to scale only user registration microservices. You don't need to increase the other microservices. But if it's monolithic, then you have to scale the complete application. Even though the other functionalities has a very less traffic, still you need to increase the monolithic application if it is having a if a single unit is having a large traffic. But for microservices, it's since it's independent, you can single deploy and scale that single unit, and rest of the microservices, since the traffic is less on those microservices, you don't need to scale those microservices. So scaling a microservices architecture is easy in case we have a large traffic. Failure in one services does not impact the entire system. So suppose there is a failure in a single microservice. Again, I will say that the user's service is having a issue or it is down. In that case, the new user will not be onboarded into your application, but still the existing user can still purchase the products because the other microservices like the inventory or product microservices, the order microservices, the payment microservices, these microservices are independent and will be in function. So the existing user is still going to use those services. Only the new onboarding user will be impacted. But in monolithic, if a complete system is down, you cannot perform or the end user cannot perform any single operation. Now, microservices architecture supports DevOps culture and CI/CD pipelines. So I will not go very detail into it. So DevOps culture is that DevOps are basically used or a team which helps in deployment of the microservices. And CI/CD is continuous integration and continuous deployment. So these are basically the process to speed up or smooth the process to develop the microservices and deploy the microservices on the environments. Yeah. Now, So benefits of microservices. So first is it is flexible. Each services can be scaled independently. Time to market, teams can work independently on different services. So if a new feature is added into that in a single microservices, we can deploy that microservices and that functionality will be live to the end customer. So it is easy and it takes less time to deploy any microservice. Maintenance services are smaller, easier to test and maintain. So since the service is small, the code base is less. So testing time is also going to take less. Usually we are getting a single microservices. When you build a single microservices, it will take 20 to 30 minutes to build a complete microservice. Failure in one service do not affect other. So this we already discussed. Technology diversity, use the best technology for each services. As I mentioned that if there is a new functionality and it is better to use Python language, then we can go for it if we are using a microservices architecture. But if we are using monolithic, it is hard to do that. Resource efficiency, resources are allocated per service, reducing overhead. So suppose we have a traffic more on a product service, then we need to provide more resource to product service. The rest of the service we can keep the resource low or minimum. But in case of monolithic, since it's a single unit, if a small service needs a high resource, then the resource of the complete monolithic architecture needs to be increased. Now, what are the challenges of microservices architecture? So microservices is a highly distributed system. Okay. Since we discussed that each microservice will be deployed independently. So simple method calls in monolithic architecture will become remote calls and network issues. Now, since the microservices are different, if one microservices needs some information or some data from other microservices, then that microservice needs to call that or the dependent microservice using a REST API. So it is going to have a network call over it. Is my screen visible? Because I just lost the electricity.
So the screen is visible.
Okay. Okay. Yeah. Next is integration issues while integrating the microservices. Now, since microservices are independently deployed and they interact to each other via network or API calls. So there is situations where integration issues can come while testing the microservices. Now maintaining compatibility with dependent microservices while upgrading. So whenever one microservices is upgraded, we need to check that upgrading a single microservices does not affect the other microservice. Next, troubleshooting and debugging is complex because if a single flow is impacted or affected, then we need to identify that which microservices is causing the problem. So since the flow will be interacting with all the different microservices, so we needs to identify that. So identifying that issue is also a problem in case we are using a microservices architecture. Now, to solve these challenges, we usually have different principles to solve this microservices issues and challenges, which we can use to overcome these problems. So one of the principle is that the microservice should be cohesive. Elements that are tightly related to each other and change together should
Sir,
stay
sorry to
together.
interrupt.
Uh-huh.
We are on the slide benefit of microservices. So I think the slides are not moving.
Okay, so let me reshare the screen. Just
Yes,
give me
sir.
a minute. The electricity is back. So let me.
Sure, sir.
So on which screen it was there?
We are on benefits of microservices.
Okay. Is it visible again?
Sir,
Screen?
only benefits of microservices. The same screen is visible.
I'm just stopping the screen sharing and we'll reshare.
Yes, sir.
Okay, so now I'm sharing challenges of microservices architecture. Is
Sir,
it
at the moment, the slide is blank.
you're not able to see my screen?
Sir, I can see the screen, but it's a blank slide actually.
Is it visible now?
No, sir. Dear participants, we are resolving the technical glitch, and sir is again beginning with the session. So
Is it
please stay
visible
with
now?
us. Yes, sir.
So what is the slide that you can see right now?
The slide is challenges of microservices
Okay,
architecture.
okay, fine, fine. So let me continue again.
Yes, sir.
So in benefits of microservices, we already covered, right? So
Yes,
did anybody miss this or we can continue with the next
sir. We
slide?
can continue further. We have already discussed this.
Okay. Okay, so challenges of microservices architecture. So microservices is a highly distributed system. Simple method calls in monolithic architecture will become a remote calls and network issues. So since microservices are deployed as a different independent unity, so whenever a communication is needed from one microservices to another microservices, it needs to interact via network calls, which is a API calls. But in monolithic architecture, since it is a single unit, the different functionalities can just do a remote call or a method call to achieve that. Now, integration issues while integrating the microservices. Since the microservices are deployed as a separate unit, so always there are challenges when we integrate or test the microservice as a complete solution. So there are times when integration issues comes when we are testing the microservices. Maintaining compatibility with dependent microservices while upgrading. So suppose we want to upgrade one microservice. So what will happen is that that update should not affect the other microservices. If upgrading a single microservices is going to impact other microservices, then we need to update those dependent microservices as well. Next, troubleshooting and debugging is complex. So whenever there is any issue, it is difficult to identify which microservices is causing the issue, because for a single flow, it could be that that single flow was, that single flow interacted with multiple microservices. So we need to identify that among all these microservices, which microservices the issue is. So that troubleshooting and debugging is sometimes complex. Now, to solve these challenges, we have certain principles which we can use, or some patterns, design patterns, some principles which we can use to solve these type of problems. Now, one of the principle is that microservices should be cohesive. What it says, that elements that are tightly related to each other and change together should stay together. The logic that changes together stays within the boundaries of the same microservices. Each team can operate independently. So suppose there is a functionality which are dependent, like when we are doing a, when we are placing the order on a e-commerce application, then order and payment are very tightly coupled operation. So we should not make a separate service for order and payment. Instead, we should keep the order and payment service in a single microservices. So what will happen, that whenever we need to update a dependent microservices, since we are keeping the dependent microservices together, it will not impact the other microservices. Now, microservices should follow single responsibility principle. So each microservices should do only one thing. So the functionality of a microservices should be very clear. It should not be that, it should be like ambiguous, or it should not be very confusing, that what this microservice should do and what all functionalities we should add to this microservice. There is no ambiguity about where new functionalities need to go, which team owns that. Created easy to follow APIs. Terminology is bound to a given context, like user service should have all the user context, like user logging, user registration, user authentication should all lie to user service. Product service should be bound to products context. That means searching a product, adding a product to a cart, exploring different products, filtering different products should all be part of product service. Now, different components of microservices. So these are the different components. So we have API gateway. So API gateway manage requests, routing and load balancing for microservices. So all the requests that we send from the mobile app or the website is landed to the microservice via API gateway. So API gateway plays the role of which request should be sent to which microservice. Also, it handles the load balancing. Load balancing means that if we are having lots of traffic, then the distribution of traffic over the microservices is also part of API gateway. Next component is service discovery. identifies available service and routes traffic to them. So service discovery is a service which has the mapping of all the services, and API gateway when it needs to redirect any request to the service. First, API gateway interacts with the service discovery, asks the service discovery that I have this request, which service I needs to forward to it. And then once the service discovery components provide the appropriate service back to API gateway sends that service to the backend microservice. Next is database per service. So each microservice has its own database to ensure data consistency. Message brokers, so these enables asynchronous communication between services. So the message broker are basically the message queues. So we use technologies like Kafka and RabbitMQ. So these message broker usually work like we have some producers and we have consumers and we have a message queue. So whenever a producer produces messages on the message queue, consumer consumes those messages and process that. Next, we have monitoring and logging. This tracks the performance and health of the services. And the last is the containerization. Use of containers, example Docker, to encapsulate services for portability and scalability. So containerization is the actual technology that made the microservices possible. So you can think a container as a a box in which your application, your microservices, and all its dependencies are inside that box, and that box we call it as a container, and it is run independently, which we call the running container as our running microservice. Now these are the some case studies or use cases. So Amazon moved from a monolithic architecture to microservices to enhance scalability and flexibility. So initially, Amazon started with monolithic architecture and it moved or migrated its monolithic architecture to a microservices architecture. Uber. Uber initially started with a monolithic architecture, but switched to microservices to manage its rapid growth. So Uber was also a monolithic architecture based application. And when users started having more users, so once the Uber user base increased, Uber also had to migrate its monolithic architecture to a microservices architecture. Netflix is also based on microservices architecture. So Netflix from the beginning followed the microservices architecture. Now we will talk about the e-commerce application. So e-commerce application, the major functionality we can again divide in user registration, browse and search for products, add them to cart, ordering the product from the cart, and product delivered. So this is the high level architecture. So actually I have simplified it. So this is a very simplified high level microservices architecture. So we have user. So we have user. Okay, user can interact with an application using the mobile phone or the laptop. So all the requests from the mobile app or the website goes to API gateway. API gateway authenticate that user, or in case a new user is there and user is registering to the application, then API gateway will register that user to the account service. Before this, API gateway will also interact with the service registry component, which I have not shown here just to simplify the diagram. So API gateway will first interact with service registry and forward that request to account service if we are handling user authentication or user registration kind of functionality. Next, if a user is exploring the product, searching for the product, in that case, the request will again come to API gateway and request will be forwarded to inventory service. And in case user is ordering the product, it will interact to the order service. And if user once the order is placed, then the shipping service will come into picture to deliver the product to the end user. Now each microservice will have its own database. Also, the each microservice also needs to interact with each other. So in that case, these microservices will also interact with each other over a API. So this is a complete kind of a simplified architecture for a e-commerce application. Next is the event-driven microservices architecture. So in this case, I have taken example of an application which is developed in automotive industries like Uber, or in Herman also we have automotive applications, and there we are having this kind of structure. So here we have again the mobile app and websites in which they can, the user can check the vehicle details, the different driver behaviors, and other information on the mobile apps. Also, the vehicles interact with the backend microservices via message broker. So message broker, as we discussed, is a kind of a queue. So vehicle publishes events. So vehicle here act as a producer and publishes events to message broker queue. So events could be something like when we book a cab on a Uber, we see that the cab is traveling to our location to pick us. Now these locations are actually sent as part of events to the backend message broker. So the locations are like every 20 seconds or 30 seconds, the vehicle sends location to the message broker, and we are able to see the updated location of the vehicle on our uh, Google Maps or the map application of the Uber. So here also in automotive, these are the microservices which we have. We have a vehicle details microservice, which stores the all the vehicle related details. We have remote operation microservice. So if we perform some operations from mobile app, like we can uh, we can access, or we can do operations like opening or unlocking the car or vehicle's door. So we can actually have in the app, we see a unlock button. On clicking the unlock button, the request goes from mobile app to the API gateway via this API interface. Then API gateway sends the request to remote operation. Remote operation sends one event to message breaker. In this case, producer will be remote operation, which will send the request to message broker, and this message will be then sent to the vehicle. So this is the way the automotive microservices architecture are designed in a high level. Next, these are the technologies that is used by Netflix. So I will not go in very much details on these technologies, but at least I will tell you the names of it. If you guys want to explore more on these technologies, you guys can explore. So for Netflix, the front end, the mobile app, and the websites are developed using these technologies. So this is the Swift. Swift is used to develop iOS application. This is Kotlin. Kotlin is used to develop Android-based application. This is React. React is used for browser or website. This is GraphQL. GraphQL is a query language. It acts like a API. So, and this is the REST APIs that interacts with API gateway. So these two act as a API and interact via API gateway. The difference between API and GraphQL is GraphQL is a query language. So it is used in case we are doing functionalities like searching a product, filtering a product on our application, then or in case of Netflix, if we are searching for TV series or movies, then GraphQL comes into picture. At backend, we use these applications. So Zulu and Eureka are the services like service discovery or load balancing. Spring, this is a Spring technology. This is a Java-based technology or framework to create backend APIs. Next, we have EV Cache. It is used for caching. Kafka is a message broker, or the message queue or the message broker. Cassandra and CockroachDB are the databases to store database. Flink is a technology for data processing. Next, for streaming, for the video and movies streaming, Netflix uses Elastic Transcoder, AWS CloudFront, and AWS S3. For big data, it uses for data processing, it uses Flink, Apache Spark, Tableau. For data storage, it uses Amazon Redshift, AWS S3, Druid, and Iceberg. So these are the technologies which is used by Netflix. Next, challenges in implementing microservices. So managing multiple services can be more complex because we have now multiple microservices. Data consistency, ensuring data consistency across services can be challenging. Distributed system networks, network latency, failure handling, and service discovery need to be managed. Increased overhead requires more infrastructure and resources to manage. Security concerns, protecting communication and data between services. Testing challenges requires integration and end-to-end testing of services. Now, these are the key tools that we use to develop microservices. So first is containerization. So Docker and Kubernetes are the technology that help us to create containers of our microservices and run those containers. API gateway, or to manage the API, we use technologies like Nginx, Kong, APG. For discovery, service discovery, we can use Console or Eureka. For message broker, we can use Kafka and RabbitMQ. For monitoring and CI/CD, CI/CD is continuous integration and continuous deployment. For this, we can use tools like Prometheus, ELK Stack, continuous integration. We can use Jenkins, GitLab CI, and Circle CI. So finally, we can conclude that microservices offer significant benefits in scalability, flexibility, and fault isolation, but come with challenges like complexity and distributed systems management. Consider microservices when building large, complex applications that require high scalability and independent deployment of components. So that's it. So that is all about microservices. And you can connect with me on LinkedIn or on my YouTube channel. So I have a LinkedIn profile. Also, a Crypt is the name of my YouTube channel. So you can connect here. So thanks all.
Thank you, sir. Thank you so much for the enlightening deliberation. I am sure this insightful session has enlightened the participant about microservices, and I would say their importance in the present scenario. There are certain questions by the participants, which I would now like to take up with your permission.
Fine, fine. We can take the questions. Let me stop the screen.
Yes, sir.
Yeah.
So the first question we have, if an application runs on thousands of microservices, how would they be individually managed?
Okay, okay. So usually we don't have thousands of microservices. So we club the microservices. Usually we can have 10, 20 at most. And we actually creates different instances. So if a traffic is increased, then we create, like if a user service is having more traffic, then we will increase user service instances. So there will be like 2 or 3 instances of uh, user service. Also, thousands of microservices is not possible because it is only possible in case we are developing microservices for each and every single functionality. Also for handling, the traffics and all, if you are having suppose we have a huge application which has, lots of 20 and 30 microservices. So manage those, we have these technologies like Docker and Kubernetes. So Kubernetes is a technology which I think the participants can go into details. So right now I'm not going because it's a huge topic. So Kubernetes actually help us to scale these applications and handle these traffics and all. Also, the resource uses we talked about, that we can assign different resource to a different microservices. So these resource uses, the traffic, the scaling of the application are all handled by the Kubernetes technology.
Yes, sir. Sir, another question we have, what are the vulnerabilities associated with these microservices itself? Because each one of them may have different tech stack.
Okay, okay. So you see, to develop, when we are developing in the organization, to check the vulnerabilities, we have certain tools. So there is a Sonar. Sonar is a tool which checks the code quality. We have tools which check the security vulnerabilities. For that, we have tools like Checkmarks. Checkmarks is a tool which is this is a tool which checks whether there is any security loopholes inside our microservices. And then we have a Black Duck is also another service which checks whether there is any vulnerabilities in the dependencies which is used by the microservices. Now, these vulnerabilities we usually check as part of our development and also as part of our CI/CD, the continuous integration and continuous deployment process. So whenever a team works on a microservices and develops and add new functionalities or feature to that microservices. Once the everything is done, the dependencies are added into the microservices, the code is written into the microservices. Then before deploying that microservices, the microservice need to go through these steps. Like first, we need to check the code quality. So we can use the Sonar tool to check the code quality. Next, it will go to the security vulnerability check, where the checkmarks tool is used to check if any vulnerabilities is present in the microservice. And then we can also check the dependencies vulnerabilities. And if any issue is found, then we need to check that what are the ways to remove those vulnerabilities from the microservices. So usually what happens that suppose I'm using a dependency which was developed in 5 years back. So what will happen that since hacker has exploited that application which were developed 5 years back, so it could be that that dependency is having certain vulnerabilities. So when my application will go into these phases, the quality checks where I'm checking the code, the security vulnerabilities, the tool will report that this dependency, which is developed during this time, and this is the version of the dependency, it has these many vulnerabilities. And the tools also suggest us that after that, the new version of a dependency is available where these vulnerabilities are reduced. So we need to now use the new dependency to remove those vulnerabilities from our microservice.
Absolutely, sir. Sir, one other question we have from an enthusiast. What technology should a beginner actually know to start working with microservices?
Okay. So see, so microservices interact mostly with API. So a beginner should learn to develop the APIs. Now, the most programming languages that are used for developing these APIs are Java, Python, and Node.js, and also Golang, I will say. So these four programming languages are used more in industries for developing APIs. So a beginner should start with APIs, and once he has more command and more expertise on developing APIs, then he can plan on learning about the message broker or the message queue that I talked about. So the beginner should start with developing the APIs. In Python, there is a framework which is called Fast API. So the beginners can learn Fast API framework to develop APIs in Python. And for Java, it is a Spring Boot application. We also see in that Netflix diagram, there was a green leaf, which was the logo for a Spring. So for Java, you can use Spring Framework or Spring Boot to develop APIs and microservice. In Python, you can use Fast API.
Absolutely, sir. Thank you so much, sir. Thank you so much for this wonderful presentation. The complexity of microservices architecture you have so simply explained in this complete presentation that I think even beginners are now all motivated to take up microservices architecture, at least start working on it. So thank you so much, sir. And
Yeah, thank you.
BVI
Thank you.
BVI CAM is very thankful to you to have for having spared this time and had this session today. Our director, honorable director, sir, Professor M.N. Huda, sir, could not be present due to an urgent meeting. But obviously, we would like to thank you today for this session. So, sir, please accept this small e-memento and certificate from BVI CAM as a wonderful remembrance for this wonderful session today. Thank you so
Thank
much,
you.
sir.
Thank you. Thank you, Dr. Ritika.
Here is your certificate, sir. And we have a small e-memento because we are in an online session today. So please accept this e-memento and certificate from BVI CAMP as a wonderful remembrance to this wonderful session. And we'll hope we'll have more such sessions in the future on advances and further applications of this technology. Thank you so much, sir.
Sure, Dr. Ritika. Yeah, thank you.
Thank you, sir. And thank you, Anil, sir, for bringing Abhishek, sir, today, making this session possible and enlightening the participants about microservices and motivating, I would say, some of them to even try out this microservices architecture. Thank you so
Thank you,
much, sir.
Dr. Ritika. Thank you for giving this platform. And thank you, Abhishek. It's a wonderful session. Thank you. I really enjoyed it. Thank you.
Thank you, sir. So once again, thank you, Abhishek, sir.
Stopping.
And dear participants, okay, Anil, sir.
Thank
And dear participants, with this, we come to an end to this wonderful session today on microservices architecture. Feedback link for today's session has already been circulated in the chat window. I request all the participants kindly click on the same, fill in your details carefully, and generate your certificate of participation for this session today. Uh, it was a wonderful session today on microservices architecture. Before leaving the room, please do generate your certificate of participation for this wonderful session. Once you receive your certificate of participation in your inbox, you're most welcome to leave the meeting room with a promise to join us back on 29th of March with our next webinar session on another important topic. So, dear participants, thank you all for being part of today's session. Please submit the feedback form and generate your certificate of participation before you leave this meeting room today. The feedback form link for the certificate of participation generation has already been shared in the chat window. Once you submit the feedback form, please refresh your inbox and you will receive your certificate of participation as an email attachment. In case you do not find your certificate of participation in your inbox, please refresh your spam folder. It may be there. If it is there, please mark it as not spam. If you do not even find your certificate of participation in your spam folder, you're most welcome to share your email with all the panelists in the chat window. We are there to help you out with your certificate of participation.